Welcome to the webinar hosted by SEP Software. I'm Richard Yeager, Marketing Manager for SEP, and today I'm joined by Lanai Bain and James Delmonico, also with SEP, as well as John Hoffer with Red Hat Storage. Lanai is the VP of Business Development for SEP and is responsible for North American business development and channel partnerships. James is our Senior Engineer and has been with SEP for several years. He knows his way around the software and can answer any in-depth technical questions you may have. And lastly, we have our Red Hat Storage guest speaker, John Hoffer. John has had more than 15 years of storage administration and architecture experience, and we're happy to have him join us today and talk more about SEP's role in Red Hat storage environments. Everyone, a brief overview of what we do and then to a live demo of our software in a Red Hat environment. Feel free to ask any questions along the way by using the question box in the GoToWebinar dashboard on the right-hand side of your screen. There will be a couple of Q&A sessions throughout the seminar, so please don't hesitate to ask. And without further ado, let's take it off to Lanai and get started.
Hey, thanks, Richard. Appreciate it. So this is Lanai Bain. Just wanted to welcome everyone. Thank you guys for taking the time. We appreciate your time. We know you guys are very busy. Just going to start out here with a quick overview of SEP, kind of who we are, what we do, what we focus on, and I'll be followed by a similar presentation with from John Hoffer, who was kind enough to join us today, and he'll go over a little bit about Red Hat Storage and some new and exciting stuff that they've got lined up. So without further ado, SEP began as a German-based company a little over 20 years ago, and originally we were a production automation company, and were hired by some customers at the time to write some applications to back up some mission-critical data in some warehouses. So that was very effective and well-received, so we decided to split that off as its own separate product and bring it to market. So SEP has been on the market for over 20 years now. It's been completely rewritten from the ground up several times, and we came into the U.S. market about 5.5 years ago now. We're gaining market share very quickly and have a very solid product and quite a large market share in EMEA that we're transferring over to the U.S. market and South America as well. So main principles for SEP. There's three main things that we really focus on as a company. The first one is giving a user or enterprise one solution to manage their entire infrastructure when it comes to backups and disaster recovery. So we find that a lot of folks that we talk to and that we work with, they have multiple solutions in place to meet their backup needs. So a lot of people will have a solution for Linux. They may have something different for Windows. They may have another niche product or something for their virtual technology. And so because we support such a wide range of operating systems, databases, groupware, cloud platforms, etc., we're able to help organizations get rid of 2, 3, 4 solutions, put one backup solution in, and just have one central management console to do everything. Whether it be all in one location or spread across the globe, it's very easy to manage a very complex, large enterprise infrastructure with one console. Even one individual. The second main thing we focus on is performance. So we use multi-streaming technology, and that allows us to back up an unlimited number of streams to disk, or we can back up 64 streams per tape drive if we're backing up to tape. So in the case where we have 4 tape drives, we can back up 256 streams at the same time. And again, unlimited to disk. So this really decreases backup windows. We see a huge increase in performance over our competitors when we replace our competitors. And just really the main backup, the main hurdles that we face and the main bottlenecks we come up against are pretty much hardware and network based. So as long as we have the throughput and the bandwidth to use, we can maximize that, and you can see some very high performance. The third main thing we focus on is reliability, and this is kind of ingrained in our company from the get-go. Like I had mentioned earlier, we are a German-based company originally, and so some of the laws in Germany are quite a bit different than here in the U.S. And so one of the laws that I think is a good law and benefits our customers is that as a German company, when we tell another company in Germany that we're going to back up their data, we as a company actually become financially responsible for that data. So obviously very different than here in the U.S. where most people click a checkbox or sign a form and it says, we've promised that this will work, but if it doesn't, we're sorry, and there's nothing that anyone can do about it. We're held to a much higher standard in Germany with the software, so that reliability is there. Anytime you get a backup task or get a notification that a backup task or a group was completed successfully, you can rest assured that that data is going to be there 100% of the time. And unfortunately, that's not always the case with some of our competitors. Kind of lastly on this slide, it's not something that we really focus on or try and use a main advantage, but I do think it is relevant, and I think it is important for folks to know that when it comes to cost, that's another large advantage that we have. We come in at about 40% of industry average for backup software. So we're also extremely price competitive, and a lot of times companies can see an immediate ROI when switching over to our solution. Just a quick slide to highlight some of the main products, kind of more mainstream products we support. So going left to right, on the left-hand side, you can see that we support most main operating systems. And when I say we support these, actually, you can install SEP's main console on Windows, Linux, or Solaris. So we're not limited to only a Windows 2008 R2 server, which is one of the reasons that we work closely with Red Hat. If you do have a full Red Hat environment, this is a solution that you can use and put it in your native environment. You don't have to go out and license another Windows server, do something like that. Also, if you are running Solaris, you can install it in Solaris. So it gives quite a bit of flexibility there. As far as the applications go, support all the major groupware applications, Exchange, GroupWise, Lotus Notes. All of those have single file, single email restore capability, single user restore capability, so it gets pretty granular there. On the database side, Oracle, MS SQL, SAP, IBM DB2, all the main databases are fully supported as well. And then on the right-hand side in the upper corner, we do support all the main hypervisors and virtual technology. And in the next year, we also plan on supporting KVM as well as soon as their API is released. And then also bottom right-hand corner, we do support Linux, both Linux and Windows for bare metal recovery, and that does include that operating systems as well. As far as the performance goes, here's just a kind of little quick diagram overview of what a situation could look like using multi-streaming. So on the left-hand side, we have about 9 servers and all different operating systems. One of the main differences with SEP is the way that we schedule things. So we're actually able to schedule backup tasks in groups. So we could kick off one backup task that would just start all 90 servers backing up at the same time. And we could have one stream going from each server, or we could have multiple streams from each server. So we could break down further, and we could say, okay, let's back up all the databases separately. Let's back all the virtual machines separately. So we could be streaming 5 streams from each one of these servers if we wanted, and that really is just going to decrease backup windows. We're going to see, we usually see, depending on which competitor we go up against, we usually see anywhere from about a 50 to a 98% increase in speed and decrease in backup windows when we go head-to-head with other people. Quick couple examples of just some of those overall concepts. Vodafone, they're the partner company of Verizon in EMEA, and they're currently using SEP in 1,500 remote locations, and over this next year and a half, they're rolling us out to another 4,200 locations as well, I believe. So very good example of managing a large environment with a lot of servers in, thousands of different locations and being able to manage that entire infrastructure from one central console. Similarly, the Guardia Civil has this rolled out countrywide to 450 sites in Spain, and they're basically the equivalent of kind of a hybrid between the FBI and the patrol organizations together. So a little bit closer to home, National Archiving and Record Administration. We took over their enterprise email system about a year and a half ago, and their backups had previously, with their other solution, been taking over 6.5 days for a full backup. And because of our multi-streaming technology, we were able to get the first backup that we did with them down to 13 hours. And then after a little tweaking and some configuration changes, we further reduced it down to 11 hours. And similarly with the Port of San Diego, their backups were over 100 hours and would often not even finish because they would fail before they were over. And so we were able to get them consistent backups on a daily basis, and their entire backup window went from over 100 hours down to under 4 hours. So they went from, doing a backup for 3 or 4 days down to doing full backups overnight in under 4 hours. Their Oracle databases, I think they were particularly impressed with, went from about a 4-hour backup window originally down to about 42 minutes. A couple other product features that we have that we'll just kind of go over real quick. We do archiving, so we have a data archiving solution that's built into our product, uses worm technology. It's all managed from the same console. It's extremely easy to set up, and we can have an archiving solution up and running in literally a couple minutes. We also have deduplication, some different deduplication options built into our software as well. And one of the other things that I like to mention is just the fact that we use all generic drivers. And what I mean by that is we rely on the operating system to provide us with drivers. So a lot of our competitors write their own custom drivers for different, scan units or tape drives, tape libraries, NAS devices, etc. And so I think we have a huge advantage by using the operating system drivers, because basically any type of media that's recognized by the operating system, we can back up to. So we're not limited to, just what drivers we have available at the time, or, if a new solution, new hardware solution comes out and somebody wants to implement that right away, don't have to wait for us to develop a driver for it. They can just plug it in, put some data store space on it, and they're set to go. So we're very flexible, work with pretty much any type of hardware out there. Obviously do disk to tape or disk to offsite cloud. We have some capabilities where we can write directly to a SAN environment as well, keep everything off, keep all the network traffic off of the network. So there's also some performance enhancing things that we're able to do there as well. We also offer bare metal recovery, as I mentioned, for Linux, Windows, and Windows workstations. If there's any questions about that, we can get into that a little more detail. Basically, it just gives you a bootable image file to restore partitions, operating system, everything. So it's quite a time saver in the case of a catastrophic failure or disaster. As far as our virtual technology goes, we support all major virtual platforms, so VMware, Citrix Zen Server, and Hyper-V. And like I said, we'll support KVM as well once we have a API for that. On the Citrix side, some cool things that we can do. We've actually figured out how to prevent activation loss. So in the case that a virtual machine goes down, you can bring that back up right away, and you don't have to enter in a Windows product key if it's a Windows machine. And also that goes for any third-party software on that VM as well. On the VMware side, we have some of the newer things that we have. We have change block tracking, so that enables us to do full backups of the VMs themselves, and then also do incremental backs on a daily basis. So obviously drastically reducing the backup windows for those snapshot backups, and just giving a lot more granularity to that solution as well. And for Hyper-V, same. Communicate with the API, VSS aware, all the same features and functionalities, being back up to the same, or being able to restore to the same virtual or to a different one, being able to back up online, or if a VM is shut down, we can back that up as well. So quite a few there. All right, I'd like to open it up to a couple quick questions before we move on to this presentation. So if anyone has any questions, please go ahead and enter those into the questions box on the right-hand side in the GoToMeeting panel. Okay, looks like we do have a couple questions here. Give me 1 second so I can just expand this box quickly. Okay, and there was a question earlier, what about Red Hat Enterprise Virtualization? And like I said, as soon as the KVM drivers or API is available, then we will support KVM as well. So yeah, hopefully that answers your question and that's clear. We're looking forward to getting that API and availability to that so that we can support KVM as well. Any other questions? Go ahead and type those in. We'll give you a quick second. And while we're doing that, let's go ahead and switch over to John. And we can let him get set up and get started with his part. All right, looks like you guys are going easy on us today. If you have any questions, just go ahead and enter them into the questions box. All right, John, thank you for joining us today. I'm going to go ahead and turn it over to Hoffer with Red Hat and let him tell you guys a little about the new Red Hat stores that they have available. And then after that, we'll kind of tie both of these solutions together in a live demo so that you see how SEP and Red Hat storage really work great together and how you can leverage both solutions to have a very open, flexible, and really dynamic storage and backup security, backup and disaster recovery and very secure system. So John, without further ado, I will turn it over to you. Thank you.
Thanks, Lanai. Good afternoon, everyone, or good morning, as the case may be. As Lanai said, my name is John Hoffer, solution architect with Red Hat, specializing in Red Hat storage. So Lanai or James, someone, could you please confirm that you're able to see my slides?
Yep, we can see it. It looks great.
Great, thank you. So I'm going to spend just a couple of minutes talking about what Red Hat storage is and show you how that can provide a very scalable and flexible storage infrastructure for your backup and archiving applications such as SEP. So jumping right in, a lot of cases we get the question, is Red Hat getting into the hardware business? Because storage often means classically means some kind of hardware, disk drives and storage arrays and elements like that, and that is absolutely not the case. Red Hat is a software company. We're going to continue to be a software company. In fact, as we look at the direction of storage technologies and our computing environments in general, we're seeing a pretty significant shift towards using software with advanced enterprise capabilities on top of general commodity class hardware to get things done pretty much at a lower cost point than we might have seen in the past with some proprietary or traditional technologies. So Red Hat Storage is software-defined storage. You might have heard that phrase in association with things like the software-defined data center or software-defined networking or software-defined compute, for example, all of these things looking towards cloud and virtualization as the new model of providing information technology capabilities to our business. So Red Hat Storage is a way of using intelligent software to aggregate resources, whether they're such as commodity x86 server systems or virtual resources such as from Red Hat Enterprise Virtualization or VMware, or even cloud-based resources, taking those, aggregating them together into a scalable storage namespace. We used to refer to it as NAS, or Network Attached Storage, because we operate with your industry standard NAS types of protocols like NFS and CIFS-SMB for Windows, but in fact there's more to it than that, especially as we start talking about virtualization in cloud environments. We also have object interfaces to allow you to store things without the necessity of a typical traditional network mount point. You can do things over web protocols using object interfaces. So being software-defined storage gives us a lot more flexibility and choice than just a traditional NAS type of architecture would. As I said, you've got your choice of deployment options. Many customers deploy Red Hat Storage for unstructured data on-premise using your typical x86 Intel class server systems from your favorite storage vendor. Let's see if I can get them in alphabetical order this time. Cisco, Dell, HP, IBM, Supermicro, even others are available. So your normal friends for servers can be used to deploy Red Hat Storage on-premise. Also, because we're running on top of Red Hat Enterprise Linux and we're software-defined storage, you could deploy Red Hat Storage in a virtual environment on Rev or VMware, for example, and it's exactly the same access methods from the application perspective to get to that scalable storage space, whether it's virtual or physical or in the cloud. We can also deploy Red Hat Storage as a scalable storage namespace on top of Amazon's Elastic Compute Cloud, virtual private cloud types of resources. So again, the same access methodologies for the application regardless of the deployment model. Now, Red Hat Storage is designed for unstructured data, and unstructured data really is the area where we are seeing the growth in recent years, and especially now. The structured data problem has somewhat been solved. There's very capable enterprise databases out there and very capable enterprise storage area network and NAS types of devices for that highly structured transactional data. But the volume of data that's really growing is the unstructured data. And we classify backups and archives, such as generated by SEP software, as unstructured data. Those backup images, those incremental backups, even the archiving save sets are generally classified as unstructured data. But unstructured data also includes just general files and folders, the stuff that's out there in the enterprise, documents, images, and so forth that are the growing data volume. Unstructured data also includes big data. Big data can mean a lot of different things to a lot of different people, but it's generally anything that's either machine-generated data like log files, RFID data, or it could just be large repositories that are otherwise unmanageable with traditional storage architectures. You need a new implementation model to manage that big data, and Red Hat Storage, scalable commodity class software-defined storage, is a great way to handle your big data problems. Object data also counts. That's more along the lines of archiving. Long tail data just implies it's got a lot of activity at the beginning, but it tails off after a short period of time, but you still have to keep that online. This is a good analogy for the archive use case that Lanai was mentioning from SEP software. This object type of data still has to be kept around, whether it's for regulatory purposes, as he mentioned, or simple business needs. That long tail data is often now best served on a disk backup solution rather than tape. So to accomplish that, software-defined storage with Red Hat storage, we have a few just basic ideas. So there's always the server on the right-hand side there, and that could be a physical system running Red Hat Enterprise Linux. It could be a virtual machine image. It could be a cloud machine image. It doesn't matter. It's just the place where we are running Red Hat storage software. A brick is just a unit of storage, and again, that could be physical or virtual, cloud or on disk somewhere. We take those bricks on those server nodes, and using Red Hat storage software based on Gluster technology, and that's Gluster with a G, based on Gluster technology, we build a volume. And it's the volume that is the scalable namespace that's exported and presented out to applications such as SEP SESM. That's the scalable disk location, file storage location that they'll use for the backup and archive data. Now this is presented out via your choice of protocols, as I mentioned earlier. NFS if we're working in a Unix, Linux kind of environment. SIFS SMB if we're working in a Windows environment. There's also a Gluster native protocol for Red Hat Enterprise Linux-based systems. And there's also an object interface, so that scalable abstracted namespace is accessible through a variety of choices. And the way you build that volume kind of gives you the capabilities that you're looking for. A purely distributed volume is something like the idea of parallel computing. Just as Lanai was talking about, the numbers of streams they're able to spin up and drive from SEP software for backup and archiving purposes, you want to have a place that can receive those multiplexed multiple streams that are coming in at a high rate of parallel speed. And a distributed volume is a good way to do that. Server with a brick married up with another server and some other number of bricks. I've illustrated 2 here, but this could be 4 bricks, 8, 64, 128 bricks. As many bricks and servers as you need to satisfy the capacity and performance requirements. We call this a distributed volume because it really distributes the file content across those various bricks and exports it out as an abstracted mount point. Don't think of this like striping, for example, where you have a file that is spread across multiple components, and if you lose any one of those components, you stand to lose all of the data in the namespace. This is a distributed file system where all of the data is intact and granular and atomic to any one of those bricks. Now, one of the things that a distributed volume itself doesn't provide is high availability, so we also have a replica volume where, again, we're marrying up a couple of these servers and bricks, but in this case, we're mirroring or replicating the data between those 2 bricks. It provides high availability, it provides parallelism on reads, but it also would mean that you're making 2 writes, and we do that intentionally to provide high availability of not just the server component, but the data component as well. You combine those 2 volume types into a distributed replica volume, and then you've got high availability as well as horizontal scalability, and this is where I ask you in your mind's eye to try to see all of the parallel streams that SEP SESM can generate to quickly and efficiently back up the variety of platforms that you have in your environment, backing those up to Red Hat storage in a very similarly parallel but highly available and scalable manner. This is how we accomplish enterprise-class capabilities on commodity-class hardware using software-defined storage and capable software from the application side. One more illustration here just to highlight that further. Let me go ahead and build this out. So Red Hat storage, as I said, acts as the backup target location for SEP SESM, replication locally for high availability, but also, which I didn't illustrate, but Red Hat storage also has a geo-replication capability so that you can replicate data to another data center, to another continent, if you wished, and get that data off-site for disaster recovery purposes. oftentimes the most critical component, or the least attended to component, ironically, of a backup infrastructure is the disaster recovery and offset capabilities, simply because we usually don't want to be copying tapes about all the time. So here, again, integrated right into the Red Hat storage layer is this off-site replication, and we can get those backup save sets sent to another location automatically and transparently without the old task of putting tapes on a truck, for example. Another point I'd like to make on this illustration while we're here, as I said, Red Hat storage is built on Red Hat Enterprise Linux. We can run on physical hardware or virtual hardware. SEP System's backup server and their, I believe, the media server component also runs on Red Hat Enterprise Linux. Red Hat storage is not a closed appliance, meaning that you have access to the operating system, the Red Hat Enterprise Linux operating system, for additional applications such as SEP System Server. Software can run on those storage nodes. So consider that not only are you accomplishing the goal of the backup target on disk task, but also leverage those compute components that are part of the Red Hat storage infrastructure and use those for possibly the SEP System software or other applications. It is not a closed appliance. It is not a closed architecture at all. It's very open, as you would expect a solution from Red Hat to be. So just to recap really quickly here, as I said, Red Hat Storage is a software-defined storage solution, runs on your choice of commodity hardware. It is a modern, scalable architecture. It is a scale-out architecture, as matches our virtual and cloud environments that we are moving to. It's not your proprietary scale-up architectures where we just make the box bigger, use more boxes is really the difference here. Of course, coming from Red Hat, it's going to be open source with open standards. We are not going to lock you into any vendor. In any case, if you have server vendor A for your Red Hat storage and next year you wish to use server vendor B, it will all still work together because we're not locking down to any particular hardware. And as I said, your choice is deployment, on-premise, virtual, or cloud. You really can't do that with any traditional storage architecture. That is obviously limited to hardware. Red Hat storage is very scalable and very flexible. The reliability is built in, as I talked about, with the high availability and the replication capabilities. And because we're using commodity hardware, it is almost always much more affordable than traditional or proprietary storage architectures. The whole point being, as we scale it past petabytes and beyond, we're trying to change the economics of the information that you have to provide to your business. So I think that is my last slide. I would be very happy to open it up to questions, and I thank you very much for listening.
Awesome, John. Thank you. And just a couple things that I'd like to point out. Like John said, this is something that is not proprietary. It doesn't lock you into certain hardware. It doesn't lock you into certain vendors, which is also really one of our core concepts at SEP also. We want to have, and I kind of joke around sometimes telling people, we're kind of as close to open source backup software as you can get without being open source itself. And so that's one of the reasons that I think this is such a great solution and works so well with us, is because Red Hat has that same mentality of giving customers options to choose their vendor, choose their hardware. And so for us, it's great because, with our partnership, we can offer a joint solution together that really does leave those options on the table for customers to use. And, a lot of folks I've talked to over the past couple of years, they want to start getting into cloud computing, they want to back up to the cloud, but they don't really always where to start. And so they'll, say, should I use Google? Should I use Amazon? Should I use a private cloud? Do I want my data to be in Singapore or, Malaysia or Kuala Lumpur or somewhere overseas? Or do I want all my data to be in, in the U.S.? And so to me, Red Hat Storage looks like a very simple option to give people all of the tools that they'll need to make those decisions very easy. And so they can say, hey, we want to use the cloud. We can use it for that, but we also want data, in A, B, and C locations on our own hardware, and we want it to, be able to replicate in between those locations and have disaster recovery options. And so, from my perspective, this looks, this is a great solution, and we do have, customers that are beginning to use it in that way and have very good results so far. So I just kind of wanted to throw that in. So any questions for John? Please go ahead and put those in the questions box on the right-hand side. And John, it looks like everybody's taking it pretty easy on us today. Either that or we're doing a job presenting, because there's not as many questions as we normally have. So I am going to go ahead and send over to James Delmonico here, and we can begin the live demo portion. So for this part of the demo, we're just going to bring up a SEP server, and we'll be able to go ahead and see the we'll be able to go ahead and see the SEP portion of it and back up to a Red Hat server itself. So without further ado, okay, yeah, looks like we're up and running. So I'll go ahead and turn it over to James. We did have a question that came in really quick. Let's go ahead and get this answered. It says, can I use this solution to replicate a Microsoft Exchange database? And John, I'll let you field that, but I believe the answer is yes. You can back up the database with SEP, have a Red Hat storage target, and then Red Hat will go ahead and replicate that out to different locations, correct?
That's correct. As long as we're backing up the Exchange data, acting as a target for SEP to back that data up, we will very capably replicate that to another location. Just for clarity, though, if the question is being asked if we can run the Exchange database on Red Hat storage, I'm going to say no, unfortunately, because Microsoft Exchange, despite the changes Microsoft has made in recent years, it still is essentially a database of sorts, and databases are often not very good fits for scale-out storage solutions. So backup, yes. Active Exchange database, sorry, no.
Okay. Thanks for that clarification as well. All right, so I'm going to go ahead. If anyone has questions, please submit those. We'll have another Q&A at the end of the live demo portion. But at this point, I'm going to go ahead and turn it over to James Delmonico and let him begin. And James, take it away.
Okay, this is a fresh installation of the Sesame server on Red Hat Enterprise Linux 6, just the latest version from the Balance Center. The software detects any type of storage that you have. In this scenario, this is a single disk Citrix hypervisor with a couple little VMs. So this is just a demo environment. Here's how we'd make a new data storage to connect to Red Hat storage. In our software, we control the concurrency here. So I'm going to start with 25 channels of concurrency. If this were a tape target, we'd max out at 64 jobs at the same time to the same tape drive. With a disk target, it's unlimited. So you can send as many jobs at the same time. So here's our Red Hat storage. Okay, so now we have a data store targeting the Red Hat storage partition. And inside this, we create a media pool. And this governs the retention. So these are logical units. So anything we write into this weekly media pool won't be overwritable for 7 days. If we were doing weekly backup to this media, on the 7th day, we'd have 2 copies of the full backup. And then on the 8th day, the older of the full backups would be purged. Okay. So now we have our media pool created. So it's really that easy. I mean, anything that's set up with the Red Hat storage, all the replication, everything happens behind the scenes. So we just save the data into the folder, and everything else is taken care of for us. When the software does installation, it does a regression test. This green block indicates the task succeeded last time. When we connect to a Red Hat Linux or any Linux machine, we're able to see any running services. So we're able to back up databases. We're able to back up Open LDAP. We're able to do disaster backup of a image level type backup. One of the big things with SESM is group-based scheduling. And what we do is we set up a policy using groups like this. So I'm going to do an example virtual machine group. The groups help us do two things. One, it keeps a very simple schedule. We put in our professional installation, we put in 6 groups, disaster recovery, system volumes, data volumes, databases, groupware, and virtual machines. And then we schedule those 6 entities. The other thing that happens is when we actually run the schedule, the groups help us leverage the multi-stream because we're really running all the tasks in the group at once. Additionally, when we go back in to actually use the system and add a new machine or add a new client, then all we have to do is set up that client, set up the jobs, put them in the right group, and then we can walk away. The system will handle it. So it makes everything pretty simple. For example, I'm going to connect us to our hypervisor. This is the same thing that you'd see with any of the common hypervisors. So we had a client, we talked to a member of the hypervisor pool, tell the software which OS we're connecting to, put in our authentication information. This data mover is where SESM controls routing. And so this will control the initiator. In this case, we haven't installed anything on the Citrix host, so our only option is our local machine. Commonly, we initiate this directly from the storage. So if we have another media server out there, we'd set it here so the connection would go directly from the hypervisor pool to the storage. In the case of Red Hat storage, then we're able to do backups from each machine directly onto the Red Hat storage at the same time. And so the replication handles the multiple files being transferred in both directions. Okay, this is the source browser window. This shows us the tasks that are possible in the machine. I'm going to select a couple here. And then to put them in the group, I just select the group. And add a couple more. This firewall machine here is the only machine with a real internet connection. We're all outside this data center. This RHEL 6 machine is us. So for the demonstration, what we'll do is back up the firewall, which is actually the production router for our connection here. We're remote desktop in through it. And the idea is just to show that you can use Red Hat storage and do VM snapshots real fast with SESM and not interrupt any type of activity that's going on. Okay, so now we've added our client, we've added our tasks, and we've put the tasks in the group. So we can see here that our tasks are in the group. We can control the runtime order in the group. So to emulate what the schedule would do, I'm going to do immediate start of a full backup. Everything created on client side as far as backup jobs from clients is here, job state backup. And we see a meta task for the group and also the individual jobs. Inside the properties for the jobs, we keep this metadata in the database. And the idea there is just we keep a very small database instance, so no maintenance is necessary. We handle it all in our own folder. We can see that it was, in this case, a copy level backup. We weren't doing full or incremental tracking. The Citrix API just doesn't export incremental information. Target media pool, overall size and throughput. Then the actual log for the transaction, this is the output of the agent, is saved here in file system. And that's how we keep the database instance small. We use this, we can see this would be F for full here, or D for differential, or I for incremental, so we can tell what type of job it was. then we use this date tag, so we can tell exactly when the job was started, and then a UUID here. Every piece of data related to this backup has this exact file name. So the log files, the actual save set itself, everything. And the idea there is that it makes things easy to find and sort by date. So we can see here that we've actually completed the snapshot and we're pushing data without any interruptions. You can run, hypervisor level snapshots whenever you want with the system. From an admin point of view, this data log contains everything that's happening on the back end. So what that means to you is that you don't have to call support for every little thing, because you can actually see, oh, tape's getting loaded, tape's unloaded. We're checking the size of the storage. We're checking that our folder exists. This shows us everything that happens in the system. Also, the GUI does logging. We use this for a couple things. I use it for report building here. We're able to just add, whatever columns we want. And then the software actually generates this SQL call here. We can use that in the email notifications. So that lets me do a lot of, real simple custom reporting. So let me show you what a little file backup would look like. Let's say we wanted to create a new backup task and backup, say, this folder. So we now created our job. Do immediate start, full backup. You can see down here that there are 2 streams running right now. Okay, and that one completed. So you can see in our job states backup that this rel job completed. To do the restore, select the date range from when we lost our file. Select the instance of backup within the list. I can see here type F means full. If I were to select an incremental or a differential backup here, System will check this generation restore button here for me. And then I'll see a file view of everything contained in the full and incrementals. If I go and uncheck the button, then I'll see just the data in that incremental. System uses intact save sets. So whenever a file changes, we back up a whole copy of the file. That means that you can restore incrementals without having the parent available. It also gives you a lot of latitude to aggregate incrementals, near the client. Okay, so by default, data goes back to the node it came from, to the folder it came from, without overwrite. We can select a different folder. Let's say put it on our desktop. Okay. Here we have the save option. This is real neat. System includes the ability to do scheduled restoration. And so you can build warm standbys of hypervisors. Commonly, users restore email solutions early Monday morning automatically. That way they can service the I lost my email call without actually having to run the restore. We use it in our environment to set up standby virtual machines on isolated storage. Okay, so I started the restore. All the logs are here in JobSave's restore. I can see that it was successful. And there's my folder and my file. So that's the basis of the software experience. I think what we look at is this is a set it and forget it solution, because everything is structured with a true multi-stream Linux type Unixy architecture. Everything that you see here, this Java GUI, we use the same actual Java GUI for all operating systems. So this exact same functionality is available on Windows. You can also use other machines, anything that runs Java to run the GUI. They're not a licensed component. At this point, I'd like to open it up for questions. if you have any as far as the technical capabilities or how it'd be suitable in your environment.
Great, thanks, James. That was good. Yeah, and if anyone has any questions, please go ahead and put those into the questions box on the right-hand GoToMeeting panel, and we'll do quick Q&A, answer any questions that you guys have, and do a little wrap-up, and that should be it. Okay, so there's a question that asks, it says you said that you support Windows and Linux for the main backup server, whatever other operating systems supported. Is AIX supported? And the answer is yes. So there's quite a few other operating systems that we support. We have a full support matrix that we put on our website so that you can see the compatibility with everything. But we do support AIX. We also support all the versions of Linux, I think, after kernel like 2.5. Is that right, James?
Yeah, that's correct. Any Linux or Windows later than XP is fully supported, also Solaris. The AIX support is as a media server or a client, so we're able to operate a tape drive on an AIX server.
Okay, and also another thing too, we also do support Solaris for the main installation as well. So it's not just Windows and Linux, but also Solaris also. Okay, another question. Is this mount point a single folder in the storage server?
As far as Cessna is concerned, yes.
James, I'll let you get
the path target. We use the OS to handle the storage part. So really all we're doing is making a folder with the data store name. Inside that, there's a folder for each media pool that has a separate retention period. And then there's a virtual media folder within that actually holds our individual save sets from backup jobs. All of that's replicated by the Red Hat solution, so it's kind of abstracted for us. From our point of view, it's just a regular folder.
Okay, folks, any other questions for John from Red Hat or for SEP? Go ahead and please put those in. All right, looks like we don't have any more questions. So just wanted to, firstly, John, thank you very much for taking the time to present with us, and thanks for all the information that you provided. And yeah, we appreciated having you on. And James, great demo. I think that was a very good overview of how the two solutions, can work in tandem together. And I wanted to thank all of our attendees for joining us. Like I said, we know you're busy. We do appreciate your time. If you guys do have any questions, please reach out to us. We are always happy to help you guys do proof concepts. If you guys would like to, see different parts of SEP, if you'd like to do some testing in your own environment to see how that works, if you want to do, a head-to-head comparison against the current solution that you guys are using, we're always more than happy to give you some resources to work with and to provide you with a, fully functional trial version and help you get set up that way. So please reach out to us, shoot an email at the email address you can see on the screen now, info@sepusa.com, or give us a call, and we're more than happy to help you out. So once again, thank you everybody for joining us. Have a great rest of your day, and look forward to next webinar, probably scheduled for about a month or so from now. So we will send out an email for that as well, and look forward to seeing you next time. Thanks, everyone.